Doing a little work on the old Roadster today. Got some wiring to clean up on the engine. So this is a 4.3 liter TBI engine from an S10. These were the late 80s, early 90s models. And the good thing about TBI that I like, kind of looks like a carbureted engine, but you get the reliability of fuel injection and the better fuel economy. So I need to clean up some wiring on that. And for my wiring diagrams, using Chilton's manual. And in these, they have all the different engine configurations. And this is the one I'm using right here for a 1991. And then in the later years, they were specific to the engine size. Early years, they were all the same. But these books have all the wiring diagrams in them. So this is the one I'm using. These are all my sensors for the engine. And then over here on the right-hand side are my pin connections to the ECU. So I just took a picture with my phone, blew it up, printed it out. Gives me a little bigger diagram. So these are real simple engines to work on if it's a stock engine. You're not doing cam swaps or anything like that. You can just use the stock computer. You can get these retuned, but you have to send it off. They have to reflash the chip and everything, and it's not bad, but it's harder to find these days. So over here, I have my pin connections, and I just have the ones highlighted that need 12 volt power when it's on. For example, we'll go look at A6. So A6 is one that is hot in start and run. It even tells you in the diagram, which is pretty nice. So here's what the older ECUs look like. They're pretty basic. There's two main versions of these. One, I just call it the black connectors because it's got two black connectors. And then the other one has I believe it's a red and a blue or a red and a green or something like that. They're really bright colored. They're not black plastic like this. Then inside these computers are the chips. So these chips are interchangeable. You can pop these guys out and you can interchange them. So you can just take this piece and send it off to get programmed. On these, there's a little 4-letter code, and that tells you what it is. AULF is a 4.3 liter with a 700 R4. So if you're not sure what computer you have, you can open it up, read that 4-letter code, look it up online, and figure out what your computer is. And then you can either reuse the computer if it's compatible with your wiring harness and just swap this chip, or buy a new computer. Then among these type of computers with the two black connectors, there's two versions. And I'm not sure of the exact types or the reasons, but if you see this one has a built-in chip and this one has a removable chip. This is the transmission chip right there. For the most part, we'll just call it the transmission chip. That makes it easier to remember. So just make sure you get the one you need. I do have the ones for this, but this one's working, so I'm going to use this one. I lost the computer that I bought for this because I'm using a 5-speed. So I had a computer for a 5-speed. I don't know. This is working for now. I need to find my computer. Anyways, this is my wiring jumble. This is just a stock wiring harness that I've reworked a little bit, and it's all messy, and today we're going to clean that up. So the first thing I need to do is mount my ignition switch in my dash. I've already got my gauges laid out where I'm going to want them. I like to put the key down low, that way when you're driving and it's jangling, it doesn't scratch the paint on your dash. This will be painted at some point. Now that the key's mounted, we can move on to the spaghetti monster. So like I mentioned earlier, I have a stock harness, which is this part right here. Then I have this part, which is just a universal 14 fuse, they call them like hot rod wiring harnesses or something. You can get these pretty cheap. They've got the flasher relay in there, and then they've got a main relay, which I'm using for the fuel pump and to turn some things on. I won't need most of these, but what I do need, I need a fuel pump relay that turns on, and I need power that goes to my sensors and computer. That's about it. Distributor, all that, it's all connected. There's only a few wires for these engines. I pull the dash out so we'd have a little easier access to where my electronics are going. So up on the firewall here, I've got my bracket to hold my computer. That's just a sensor that is normally on the engine, relocated it up here. Then I have two bus bars. So this one is constant to the battery, and it just connects down to the starter, and then the starter cable goes back to the battery. And then this is my key on power. So when the key is on, this bus bar energizes, and that'll power my computer and the sensors. For the mounting of the computer, all I did was unscrew the case, which is 2 halves in these. So you got the one half that has the circuit board connected to it, and then you have the other half, which is just a cover. So I drilled 2 holes in it, mounted it to that plate, and then to mount the computer, it just attaches into the bracket like that. My wiring is kind of temporarily loomed up here, and that's just because I need to keep splicing into it as I continue working on the car. So I didn't want to do a finish loom on this. And then I've got my key on power connectors, and they're going to go up to my key on bus bar. We have the 2 computer connections. So it's going to go up to the computer, obviously. I'm going to plug this guy in. Go find a zip tie to zip tie this up for now. So that's it as far as the engine electronics connections. Now I need to tie in my key. Now it's time to make the connections to the key, and if you ever forget which one's which and they're not marked or whatever, it's an easy way to figure out what goes to what. So one of these is going to be your power coming in. We'll just point to this one for now. I don't know if it is or not. Power coming in, and then one is key on power and crank power, and then the other one is only crank power, and that's for the starter. So we'll test these and we'll see which one's which. Set your meter to resistance and just pick any 2 of them. Make sure your key is in the off position. So in the off position, you should have no connections to anything, and there isn't. And we're going to turn it to the run position, which is just the first. We're going to see which 2 are connected. So these 2 are not connected. These 2 are connected. Now we're going to check in the crank position. So now turn the key to crank. Connects to that one. And connects to that one. So this is our power coming in. This is our ignition on power or key on power. And this is our crank. So this is already ran to the starter solenoid. So now I need to run this to power and this to my ignition on. And now it's time to test out the wiring we just did. So first thing I'll do is connect the battery. Alright, no smoke show yet. And then next we'll turn our key to the on position and we should hear the fuel pump turn on. And that's the sound of our fuel pump. Still no smoke, so that's good. Now we'll see if the engine starts. A little smoky from all our new paint, but other than that, runs good. So that's pretty much it for the basic wiring of the GM TBI engines. And 4.3 liters, 350s, 305s, 7.4 liter, they're basically all the same. Like I said, there are some minor differences if it's a later year, but the book covers all of them. And like I said, this is just a basic Chilton's manual for a full-size truck. It's the same as an S10. Doesn't matter. Same wiring harness, same engine. So if you're ever looking for fuel injected reliability and fuel economy, but sort of a carbureted look, GM TBI is the way to go. You can get all these parts at the junkyard. And there are some sensors and wiring, so it'll never look quite as good, but most of them can be kind of tucked away on the one side of the engine. So that's it. This is basically all you need to run the TBI engine: computer, wiring harness, a couple bus bars, and you're all set.